Okay, good morning, everyone. Seems like we are competing with Maker Faire this morning, which is interesting because my last talk was when I gave a talk at very old Maker Faire. Goes back along many years, but no problem. So this is my topic for today. I want to talk about KiCad as an educator. So I've been working with KiCad since version 4, which I think it was sometime in 2013 or 14. So I've been teaching that to thousands of students, maybe probably tens of thousands of students by now. So I've always been connecting open source software with education as probably the best option for people to learn on is open source software. So kind of going to give you my perspective on what I mean by that. So a few things about myself first. So I'm an educator, I write books, and I create online video courses. You may know me from KiCad Like a Pro, which this is the third edition. The first edition was back in KiCad 4, KiCad 4. Now KiCad 9, and very soon KiCad 10. So like a lot has happened in the meantime. I'm also a maker. So many years ago, I wrote the book, Maker Education Revolution, myself trying to understand how the maker mindset and the engineering mindset relate. And basically what is the process of learning in, I call it learning in the 21st century or learning in a high-tech society. So this talk is a bit of a blend between all of those things. A little bit about myself is that I'm a student pilot. In my old age, I decided to do something that I always wanted to do. When I was younger, engineering once, I decided to go and become an engineer. But now I thought, never too late, try becoming a pilot. So that's me trying to avoid either other planes or birds. It's been pretty common up where I fly. You look like to your right and there's an eagle at your flight level. So try to avoid other living creatures. That's the Western Sydney Airport. This is the new airport that will be open maybe later 2026. So if you happen to visit Sydney late 2026, you're probably going to be landing there. Now, I want you to pay attention to this image and tell me if there's something that's missing that typically you see in an airport. Whoever finds or whoever gives me the correct answer gets a present. There's no tower. Exactly. Hold on a second. But how can an airport operate without a tower? Well, we've got commercial planes landing in that, so you need to have some sort of control. So this is one of the first airports around the world that, of course, it does have a tower. It's just that the tower is not located where the airport is. So the actual tower, well, the installation of the tower, the controllers are situated about 15 kilometers away. The airport is full of sensors, so they can track planes on the tarmac, landing. There's radar, there's ground radar. So all this information is getting fused. The controllers are somewhere else. I don't know exactly where. Security, no one really knows. But I thought that's an interesting bit of information to know about how things are going. Of course, there's a lot of AI assistance, right, to help pilots do the job. So I actually took this picture in one of my recent flights. I did a solo flight. I managed to go close to the airport. Obviously, that is going to be a restricted area, so it was probably one of my last chances to do this. And that's another view from the same flight. Got any pilots here? Oh, that's, sorry. Let me just try again with this. I think aerodynamically, my limit for throwing this is probably around the first 3 rows. It gets challenging after that. Okay, where was I? Oh yeah, the things that I'm throwing out are actually one of Australia's most common predators. That's me on the ground after a successful landing, hopefully only successful landings. Yeah, so the things that I'm throwing out are miniature replicas of Australia's most common predator. You guys not allowed to say anything about this. If you're nosy, keep the secret. But recently we had attacks by bears. You know how in China you've got like the panda? In Australia, we've got jump bears. They will sneak up on you as you're walking down the bush and try to eat you. So that happened to a bunch of British tourists. Like I was doing this research yesterday, so it's a recent event. So just be very careful when you come to Australia. Beware of these creatures. Just to finish up with this topic, that's what they look like. They're bloodthirsty. Usually they're hungry because humans are going into the habitats and they eat the, they reduce the populations of the natural prey, so then they prey on humans. Okay, any questions about this? This is like a fork of a koala with, it really likes blood, and it's got like very sharp teeth. And actually its claws are pretty dangerous. So when you come to Australia and you go to a zoo, you're not going to see this. It's just too dangerous to live with visitors. So yeah, they keep those things in cages usually. And just to finish up with this topic, even Crocodile Dundee says, I'm not going near any one of those things. So this guy would fight crocodiles and snakes, but he wouldn't go near a jump bear because it would be too dangerous. So I'm happy to talk about jump bears and planes and aviation, but maybe time to get back to my actual topic, which is KiCad. All right, so I'm going to kind of blend a story and then come back to what I was talking about earlier in the beginning about how I see KiCad as an essential tool for electronics engineers to have one tool throughout the journey, from a beginner, right, to a university student, to a professional. One tool is the idea that I want to discuss. So one story here comes from a, hold on a second. What was it? Yeah, okay, I've got my notes here. So one story is from a forum that I came across a few years ago where a professional engineer who was using Eagle CAD many years ago decided to switch to KiCad because of the licensing changes that the parent company that makes Eagle imposed that basically jacked up the price and it closed down the system, so sharing projects were harder. So this particular engineer who had a lot of years of experience with Eagle obviously had to think carefully about making that change. So what it would be like to learn KiCad, essentially forgo all the expertise that he built in Eagle. But he made the jump. Back then, when he made the jump across to KiCad, it was KiCad 6. It took him about a week to be productive with KiCad, built his first PCB, and then about a year later, he came back and reported on his journey. Just basically was a success, and he felt the freedom of being able to publish his work, his projects, knowing that anyone would be able to just download KiCad and then view or even edit, modify his own projects. So he essentially broke the leash that he had with the original software that he was using with Eagle. And that's just a typical story. And I've actually felt this story as well every time that I've made the jump from a proprietary commercial tool to an open source tool, which is something that I'm also going through now. I'm transitioning from commercial software to open source software, so I feel that freedom every time that I use open source. So this is the main question that I want to explore and to answer today. What if you never had to switch from one tool to the next as you are learning an engineering tool, okay, which does require a lot of investment in terms of time? So what if the tool that you learned early on is the tool that you basically build your career on for life? So you never accumulate that switching cost that comes otherwise. So that is the question that I want to explore. So I call this one tool, one journey. And I call this the KiCad journey. So traditionally, just going to zoom in here so you can take a better look at this. Traditionally, this is what we go through. I actually witnessed that in my own university journey. So we start as a hobbyist with whatever free and simple, colorful tool we can find with as few options and buttons as possible. Kind of like the Arduino IDE before it became a little bit more professional, like the original versions. Very simple. Or like Fritzing, for example, for schematic design. Then you go to university. University tends to have deals with software vendors for one tool or the other. So you kind of leave whatever you learned up to that point alone, and then you start using whatever the university offers you. And then you graduate to university, you get a job, and then your company tends to have their own tool or their own solution. So maybe if you're lucky enough, that's going to be the same one as what you learned at university, or again, you have to start over, relearn something new. So each time you kind of repay the debt back, which is basically lost time, lost productivity. You've got to relearn a new tool. So here's another example, just to see what it's like if you don't have to repay the debt every time. So one example that I found is pretty prominent is it's 1-bit squared. So Piotr Estentempsky, I believe, in Germany, he wanted to create an educational FPGA development board. He partnered with Clifford Ford at a conference, and they designed the first version of the FPGA educational development board. That eventually this became a product, but the interesting thing here is that it was like 5 hardware revisions later, still the same KiCad tool, which means that the entire process was on open source software. And even today, everything is being done in KiCad, and that became a professional, successful product that people use to learn FPGA in KiCad, no debt to pay back to a commercial tool, and no fees to pay. Even though this was set up from the beginning as a commercial enterprise, which means that they could have afforded the licensing fees for commercial CAD tools, right? So that's a decision that they made early on. Let's put that there. All right, here's another example. So I mentioned earlier, I'm going through a journey right now of converting my life from commercial licensing software to open source. So one of the items, I guess, in my everyday life that I want to convert to open source is a mobile phone. So I came across Purism, and I learned, to my surprise, that this company uses KiCad to design its open source mobile phones, smartphones. It's called Purism. It's using Linux as the operating system for this phone, and of course, all of the boards that make up the insides of these phones are made or designed on KiCad. And Librem 5, I believe, is the current offering. There's just another example of what you can do with open source. So KiCad gives you freedom, obviously capability, and that capability, as we learned yesterday as well, and probably today as well, increases over time. So with every version, we get new capabilities that are bridging the gap between what you can do with KiCad and with other commercial options. SparkFun is another example. So they invest heavily in KiCad and in open source. I remember a few years ago when SparkFun released its library for KiCad, it was like a major event, because for the first time I was able to find, for example, Arduino libraries, symbols and footprints for KiCad. Prior to that point, I had to design them. So I remember in KiCad 4, I couldn't find a library for an Arduino Uno, for example, because I was also teaching Arduino Unos at the same time. So I couldn't find the library, I had to make it. That would add a lot of delays in my development process. It made using KiCad a bit more tedious. SparkFun comes in, they release thousands of symbols and footprints in the SparkFun library. It shows that the ecosystem at that point starts to grow, okay, which is what we need, and we're going to come back to the ecosystem in a moment. So that's SparkFun. Let me just zoom into this. So KiCad, one, journey, no learning debt. Traditional path, okay, you've got to learn stuff every time that you move to the next stage in your professional career. With KiCad, just one continuous growth. Okay, one continuous growth. Your learning compounds forever, and you basically don't have debt to repay. So the implications, I think, at this point are quite obvious, right? You start from day one learning a tool that you know is going to be with you for the rest of your professional life. Not only that, you can do things that you probably can't do with other tools. I remember, for example, when I was an engineering student, I think back then, I have to think back, but I believe I used Protel back in the 90s. Anyone remembers Protel? They've got a different name now. But the files that are created back then are no longer usable. I can't convert them to something that I'd be able to use to read them with. So I've got a gap in my engineering career from my first about 10 years of creating circuit boards because my university used Protel. So a few examples now about the ecosystem. Another major milestone in the story of KiCad has to do with CERN, and when CERN essentially funded the project development. This is back in 2013. CERN invests heavily in KiCad development with, I think, 2 or 3 developers who contributed quite a lot of new features in KiCad. And here's a question to you guys. What features, if you know and remember, what features that are very commonly used today in KiCad were developed by CERN? Anyone knows? Anyone? Let me just switch to the next slide, maybe. So things like the push and shove router, differential pair routing, all these things didn't exist back then. Even, I don't like the last one, spy simulation. I'll talk more about that later, but even that was at least introduced, brought in by CERN, okay? This is why, I guess, this quote by Javier Serrano answers the question as to why would an organization like CERN and many other organizations invest in KiCad when they've got other things to do. CERN has to do particle physics, so then they spend money and time with a tool that they can just buy and get on with their lives. So Javier Serrano said that KiCad could do to PCB design what GCC did to software, the compiler, ensure there are no artificial barriers to sharing. And I think a couple of speakers touched on the same topic yesterday. Okay, so I think that no artificial barriers to sharing is key here. Typically, that has to do with licensing fees, locked-in standards, or standards that can't be shared, right? Basically, they lock your work into an ecosystem with artificial barriers around it. So that's what CERN did. But after CERN decided to invest in KiCad, other large and important companies came in. I mean, large, not so much in terms of size, but in the impact that they have in the maker and technology ecosystem. So you had companies like Raspberry Pi and Arduino that decided to follow what CERN had done and invest in KiCad, invest in open source. After that, I think, at least from an outside perspective, like I'm not a KiCad insider, like I look at it from the outside, and it seems that after that, KiCad had a really upward trending trajectory where a lot of polish and real capabilities became normal and expected by its users. So the ecosystem is growing. So what does all this mean for students and for engineers? Remember in the title of my talk, I talk about the engineering mindset. Okay, so here's a question for you. Anyone who answers this question in your own way, because there's no correct way, gets a drop bell. So what is the engineering mindset in your mind? How do you describe the engineering mindset? Problem solving, yeah. It's kind of active, right? When you're trying to solve a problem, you actively engaged with the problem. You're not passive. So you're trying to research it, you try to understand what the problem is, and then you're trying to find a solution. So when I use commercial software, I can't do that, right? Because it's a black box. When I have a problem with commercial software, I go to the help desk, I type in my problem, and then I'm waiting. Okay, there's no actual thinking happening there in terms of problem solving, so there's no engineering mindset, I guess, type of solution there. So I have to wait. But when I'm having an issue with KiCad, my brain works differently. I'm not sure if that's how you feel as well, but my brain works differently. I'm thinking, this is open source. Maybe it's something that I'm doing wrong, but there's a good possibility that there's something that's broken in KiCad itself. Or maybe it's an edge case that that this sounds familiar. Maybe it's that I'm doing something that hasn't been tested against, right? So I've got a few options at that point. I can engage with a community and say, hey guys, I'm experiencing this issue. Anyone seen this? As far as I know, there's no help desk, right? There's no help desk for KiCad. There is a Discord forum where you can go and again engage with the community. There is a ticketing system where you can submit suspected bugs. But even if you do that, like first you need to research, maybe there is already a ticket submitted for that same kind of bug, right? So what I'm trying to say is that there is more work involved when you encounter a perceived issue with open source, rather than automatically, I'm just going to shoot in a ticket and then just wait. You're actively trying to fix it. Okay, that's what I call the engineering mindset. There's a lot of options. So I dare say that using open source software makes you a better engineer, and using KiCad makes you a better engineer. Let's continue. So here's something that a student told me, well, not recently, but a couple of years ago, which kind of summarizes what I just said. So in Ego or in any commercial software, if something doesn't work, I assume I'm to blame, or perhaps it's a bug, so I'm submitting a ticket. But in KiCad, there's a lot more that you can do to figure out what's going on. Okay, so you're more inquisitive, which is what you want an engineer to be. To find a better way, maybe it's a bug, maybe it's my mistake, I'm going to learn and get better at this. So that, I'm saying that mindset transfers, because the same approach to problems, when you're using KiCad, it can translate to pretty much anything else that you do as an engineer. Okay, so it's a learned behavior. This is another thing that I like about open source. So this actually happened recently, where I asked my community, because I was coming here and I wanted to put some content together, I asked my community if any teacher has any stories to tell me about either using KiCad or open source software. I didn't want to make it specific to KiCad. And one teacher said that, yeah, recently I had a problem with one of my designs, which had a bug. So the teacher actively showed his class how he discovered the bug. After building the board, implementing it, there was an issue with something in it. I think a display wasn't working properly, some pin issues. He showed his class how to fix it, but it didn't stop there. He showed his class how to report it to me, basically, because I was the original creator of the board. So kind of full life cycle. he made this bug an opportunity to teach something to his students, which was compatible with the engineering mindset. So contributing knowledge back, and that's how knowledge propagates and gets stronger. So there's also the maker movement impact, where you've got people that use open source tools to create companies. So here's one example. So Lucas Hartmann out of Germany wanted to build an open source laptop. So his mindset and his philosophy was open source all the way. So he used KiCad and other open source tools. He built this laptop composed of a bunch of different PCBs, everything in KiCad, published the schematics or the projects, the project on, I believe it's on CERN OHL, which is a library for where CERN kind of provides a library of projects, and that's where the MNT project and laptop has been uploaded. So you can build your own if you want, or you can buy this laptop already manufactured. So a few thousands of those copies have been made and sold. So it's used by engineers. Anyone who basically wants to go open source all the way can have a reform laptop, another KiCad project. And here's another example, Olimex out of Bulgaria. So they build an industrial strength microcontroller and mini computers, so credit card computers. Again, very demanding applications, because these things you find in factories with wide-ranging environmental conditions, dust, moisture, temperatures going up and down. So they build hardware in KiCad that is required to operate in a diverse range of environments. They do have the money to go with a commercial license, but they went with KiCad not because obviously it's free and open source, but also because they want to be able to share their designs with anyone. And if you go to the Olimex website, you'll be able to download the designs for every single board and computer that they make. And because they're all high quality, they are used by universities and engineering departments as references for the students. So an instructor or a lecturer will be able to pick up one of those designs and then analyze it through the course of a semester to explain concepts, for example, of high-speed design to the students. It's exactly the same thing as what Latte Panda is doing with their designs, which are done again in KiCad and published. In my last course, which I published a few weeks ago, I actually used Latte Panda's design to learn how to do high-speed design, so then I can teach it to my students. Okay, I haven't done this for many, many years, so like things have changed. So I'm going to learn from a design that someone else has made, and it's been tested, manufactured, so I know that it works. I can trust it to teach my own students. So that's how this works. All these things are real products. Okay. So if you go to the KiCad website, there is a whole list of made with KiCad projects that I occasionally browse to get inspiration and learn from. So I mentioned about the ecosystem effect a little earlier. The ecosystem for KiCad is growing. So universities, commercial companies, and maker communities using the same tool kind of trigger products and services being created to service the KiCad community. So one example, let's come back to that. Okay, one example that I came across, again, as I was preparing for this talk, is PCB Hub. And that's one, and that's circuitry at the back as well. They kind of do something similar. And I didn't know about either one, okay? That's what I'm talking about, the network effect here. So PCB Hub is under development right now. So I was talking to the developer. He started work literally maybe 2 or 3 months ago. And his ambition is to create a tool that can allow teams to collaborate. Remember, collaboration was one of the questions we were discussing yesterday here during the panel. So you can use PCB Hub to discuss a project. So there's an annotation tool. You can see here I was just annotating a part of my circuit. You can put some text to explain what the question is, or what is it that you want to focus on the discussion in particular for that part of the circuit. You can see the history of the project. You can go through versions and see how the project evolves as these questions and discussions evolve as well. So that's just an example of how the network effect for KiCad in particular works. And it shows that the KiCad ecosystem is healthy because it's growing. Okay, now I'm going to try and get this back. I'll leave it at that. Okay, so I'm just going to switch to some not so good things about KiCad. Just like anything, we know it's growing, so nothing is perfect. And because we use open source, we kind of used our tools to not be perfect. Okay, we understand that they're not perfect because we engage with the issues that we discover, and we accept that as engineers and as open source software users. So one thing that frustrates me quite a bit is the grid misalignment. because I work on a lot of different projects every year, KiCad tends to be something that I focus on maybe once or twice a year. So I kind of have to relearn some of the basics, and one of those things is the grid, which kind of frustrates me. So in the Latte Panda project that I was working on, say in July and August, I designed a bunch of sheets like this one. And you can see that when I went to do an ERC, I got all these misalignment errors, even though the lines look perfect. Like you can see the junctions are showing as if the wires are properly connected. But then I go for an ERC and I get hundreds and hundreds of errors. So I was able to deal with that, okay, very patiently. It took me a few hours, but I fixed it. But imagine a student who doesn't have my context to deal with this. They just give up. Hopefully the instructor will say, okay, deep breath, you can do this. You can fix it. It had to do with the grid. So a drop there for any of you that shares your frustrations with KiCad. Any frustration? Yes? Oh, no frustrations. Okay. But there are things that you're frustrated. Sure. Got it. Yeah. Yeah. That's like, again, if there's nothing major that you're frustrated with, it's totally normal, because even for me, this is not a major thing. It's just an inconvenience. But I'm thinking now as a student, if I was a student, this would be major, right? Another thing that I can share with you is the spy simulator. Anyone uses the spy simulator? Except for you. Yeah, you do? Yeah. Yeah, it does take work. You earned a drop bell. The thing is, I'm going to try and throw it at you, but maybe it's intermediaries should pass it back. So made it most of the way there. Yeah, so it's one of the things, like maybe 1% of people that I ask and like discuss this uses a simulator, but mostly just to try it out and see what it's like, not in real life. So maybe you can fix the grid instead of the simulator. Just a thought. But again, like we understand these issues, right? And we are committed to the project. So we see ourselves as, okay, this is frustrating and I'm going to do something to fix it, or, I'm going to find workarounds, but they're not showstoppers. Again, that is the engineering mindset. It's a challenge for us. It's not like a dead end. Library challenges, we all know about this. Like, would really like to not have to struggle finding things. Well, just rephrase. Have a centralized database so we know that the parts that we are using in our project are the latest version. And if it's kind of a centralized database, when we share the project with other people, we know that they are getting the same version, symbols and footprints as the ones in our project, without having to share perhaps hours in the project file, which could be old. You see the problem. It's just a couple of examples. And then as you go to edge cases, of course, things become a lot more specialized. So again, totally normal. I don't have an experience in any of those, perhaps, other than high-speed design. I don't have an experience designing projects that require, for example, micro vias or rigid flex boards. But I was doing a bit of research, and it seems that people do. So in this case, I need to use external tools. But again, these are edge cases, so known issues that we can use external tools to deal with. So I'm going to start to wrap it up now. Let's talk about the educational impact. I've already mentioned that most of these issues hit students the worst because they don't have the context that more experienced engineers have. So I was thinking, what can I do to help my students deal with those issues when they hit them? More about that in a moment. So we already talked about this. When you use a commercial tool, you basically submit a ticket, wait. That's all you do. With KiCad, we engage our engineering mindset and we try to solve the problem. And the process is such that the solution to the problem that I have encountered helps other users of KiCad as well. So that's the community effect there as well. Again, this is a skill that transfers to other parts of life. So we don't ask whether the tool that we're using is perfect, but again, as an educator, what do we learn from the experience of using a tool that is not perfect? Okay, we learn how to fix it. We learn how to analyze it. And then we learn how to pass what we learned to others, right? Help other users. So this is what I like about KiCad as it compares against other tools. So commercial tools, you learn to be dependent on the help desk, okay, and the vendor. With KiCad, you learn to be proactive. You learn to essentially solve your own problems, solve your issues. You learn agency, which I believe is the right attitude for an engineer. Now, I talked about this yesterday. What I would really like to see as KiCad is becoming, is evolving, and it's becoming more complex, both in terms of its capabilities and its user interface. So I would really like to see a learner mode. I'm going to research this a little more, like see if I can actually do something in that direction. Maybe a fork of KiCad, just like the Chinese version, maybe a fork of KiCad where I can hide a bunch of buttons that don't mean much for a newbie in Linux, sorry, in KiCad. A learner mode, that would be a simplified interface. And I just focus on the basics. Drop a symbol on the designer, connect it with wires, standard grid. The ERC, when you engage it and it gives you a bunch of errors, you should use proper English so student doesn't get scared. instead of cryptic language, things like that, right? So this is something that I think as KiCad especially is becoming more common in universities. I actually have quite a few universities that use my books and my videos to teach the students. So I know that more universities are investing lecturer time, student time, and resources into KiCad. It makes sense to maybe, spend a bit of time thinking about their experience. So it's something that I'm willing to look at. And if anyone is also interested in joining forces, perhaps, yeah, let's talk about this and see what we can do. So the idea is to keep the one journey promise, right? So we don't want to exclude the beginners because the tool is super capable now and super complicated, and then exclude the next generation. Like, this is something to consider. And this is pretty common in software development as well. You see pretty much any software that grows and is successful goes over to the complicated range of capabilities and user interface challenges, make it unapproachable to newbies. So we don't want to break the promise of one journey. So are there any educators here, any teachers? Thank you. You already have a drop there. So yeah, teach KiCad, teach it critically. Take the opportunities when something goes wrong. That's a teaching opportunity, okay? Explain to students the opportunity now that they have to learn because the software is buggy or they've done something that broke something. Okay, it's an opportunity to learn. Rough edges are actually good. You can transform them into learning opportunities. The example that I gave you earlier with the ERC issues and relating to the grid, I actually didn't sanitize that in my video. I showed my students, bummer, I've got like 500, actually didn't, it wasn't 500, it was like 999 plus. So thousands, who knows how many. So I thought that's a good opportunity to show students, do not panic. How to say, keep calm and fix one thing at a time, right? Stay calm. So it was an opportunity. Okay, to the developers, thank you guys. You're doing an amazing job giving the community a tool. It's just the developers here, but also the extended development community, which are, how many developers are like in the extensive way, meaning of the word, aside from the core team? Yeah, around the world, like all distributed.
Yeah, I try to send stickers to developers every year. I generally make between 150 and 200 of those stickers. So if you contribute something to KiCad, you have a version 9 sticker.
Awesome.
So yeah, it's about 200 people who do submit fixes for issues that other people report. So if you're helping other people, you get a shirt in addition to the sticker. I send about 40 of those shirts a year. So about 40 people are around the world helping other people elsewhere to make KiCad better. So
that's amazing. Yeah, just think about that, right? So that's a sign of a healthy community, right? Again, agency, people helping people and people fixing things. So thank you to the entire KiCad community and the programmers and developers. And of course, to students, early career engineers, and everyone here who's using KiCad. Document your frustrations. Frustrations is the wrong word. In a future version of this, have to change this to a different word. It's just negative, but let's say document your challenges, right? Probably a better word. Because you file an issue into KiCad, the issue becomes known to the community. Maybe one of those hundreds of developers will pick it up and fix it after verifying it. So that's how the software grows, and that's how the community grows as well. And there's a forum as well. You can discuss issues as well, find better ways of doing things. So that's how we improve the tool for everyone. Okay, so we're all in this together. Yeah. Whatever we do as a community helps the entire community. Whether you are CERN or like a big company contributing funds for development time, students or makers creating libraries. We all help each other, and that's the idea. So one tool, one journey, one community.